Hello, and welcome back to another VMK in the game development series. In this VMK, we're going to go and implement a method to add materials to our existing objects. So before, we only had the ability to render objects that were all gray. Well, now that we've added the material class, we can go and make some modifications into the scene class so that we can use these new materials with all of the objects that we'll be creating. So let's get started. First thing we need to do is make a function that will attach a material to a shape. But I guess before we do that, we should take a look at this node shape class one more time here. Inside here, remember that we commented out the ability for our shapes to contain materials. Well, now that we've finished implementing the material class in the previous VMK, we can now uncomment this line of code. Which also means at the very top here, we need to uncomment material.h. Each shape node now can contain a material, and if it does, we can go and make some modifications inside render OpenGL here according to the material we pass into it. First thing we're going to do is just at the very top inside the constructor here, initialize our material to null, since initially it's not going to contain anything until we assign something to it. Now, to assign something to this shape, what we're going to do is write a function inside scene.h. And inside here, this is how we're going to attach materials to specific objects. So let's just scroll down into here. Right here, we're going to add a new function called assign material. And it's going to take two parameters. It's going to take an unsigned integer to a shape ID and also an unsigned integer to a material ID. So what we're going to do is we're going to create a new material, save the ID number for the material, and then after we create a shape node, we can then assign a specific material to a specific shape. And it doesn't matter in which order you perform these operations, so long as you don't forget to assign material before you go and render it. So let's go and implement this function now. Inside scene, let's place it, let's put it right after delete all materials. Down here. The function itself is relatively simple. Again, we have two parameters passing in here, the shape ID and the material ID. First thing we do is we check to see if the material ID number is valid. And it's valid if it's less than or equal to the size of the current container that holds all the materials. So if the ID number is greater than that size, then we generate an error and we just return false. If we continue on down through, we know we have a valid material number. We then check to see if we have a valid shape ID. And again, we do the same check to see if the container that contains all the shape nodes, which is the same container that contains all the nodes itself, we check its size and see if this value is greater than the size of the container. If it is, it's invalid, so we return false. If it's valid, we continue on down through. What we do is we then check to see if the node that contains this ID number that we passed in is indeed a shape node. So we check the isShape function. If this returns true, then we negate it and we skip over this part. However, if this returns false, then we know that this ID number that was passed in actually doesn't point to a shape node. It points to some other kind of node, which could be a transformation node or anything else that we may have implemented. So if that's the case, we generate an error message and then we return false. And I guess I should scroll across here so you can see the full error messages that I'm generating. Nothing special here, just regular messages. If we've gotten down here, we know we have a valid shape ID node, which points to a valid shape, and we also know we have a valid material ID, which also contains some material data. We then take the node, which is stored inside of our container, cast it to a shape, since we know it's already a shape from this check up here. So this part here returns a node shape pointer. We then reference the material pointer inside of that shape. So in other words, if we go into node shape here, we're accessing this member variable, and we're going to assign it to the value of the material that's been stored inside this container. And again, this container will contain all the different materials that we're creating new as we're initializing the scene. So we take the ID number which was passed into us. We have to subtract one from it because this container itself is 0 indexed, so that's why we're doing the -1 here, and this container will return to us a pointer to a material. So we can take that pointer to the material and assign it to the material pointer that's inside of this specific shape node. We then return true to say that this assign operation performed successfully. So that's the way we go ahead and assign materials to specific nodes. Okay. Now, back inside node shape.cpp, we now have a valid material pointer. So we have to go ahead and use it down here inside render OpenGL. So we can uncomment this if statement. If we have a valid material pointer, we're going to do one thing. Otherwise, we're going to go and use the default colors, which is that gray that we've been using up till now. Everything else down here will still remain the same until we go ahead and implement textures. So if there is a valid material pointer contained inside of our shape node, this is what we're going to do. We call glMaterialFV for every single parameter that we can change according to the material. Same as what we did here. But this time we get the values for each of these ambient, diffuse, and specular straight out of the material which we've saved now a pointer to. So here you can see we're taking the pointer value for the material and we're extracting the ambient color and we're assigning it to the ambient parameter in OpenGL. We do the same thing for diffuse. We take the diffuse value from within the pointer that points to this material and we assign it here. We do the same thing for specular, emission, and shininess as well. And that's it. It's pretty simple to do since all the work was already done for us ahead of time, and working with OpenGL is relatively simple. Okay, let's save this and compile it, make sure everything's okay here. And now all we need to do is test it out. Inside initialize, let's see what we have. Actually, let's just build this and take a quick look on what we have rendering so far on the screen. I noticed there were some error messages here. Assign material. The return type should be bool. And what do we have here? Oh, this here should be bool. My mistake. And let's build that again. Okay. So currently on the screen we have our plane and a box. And we have a yellow light source which we're carrying around with us and a white light source which is shining up above in the scene. Okay, let's go inside the scene initialize and play around with the scene for a little bit. I'm going to change my light source back to be white just because it's a little bit easier to work with. Remember, if you're mixing around with different colors inside the materials, the end result of your objects on the screen is going to be a mixture between the materials that the object is as well as the color of the light source hitting the object. So if you're not getting the right color that you think you should be getting, double check to make sure your light sources are white for first thing, and make sure that the material objects are the color that you wish them to be. So that's just one thing you should be aware of. Okay, let's scroll down here and see what we have. We have a transform node, and then we have a box geometry, and then we have our node shape, and underneath that we have another transform node, then we have our flat grid, and then we have our node shape. And then we have our second flat grid. This is the one that's, I think, in front of our faces. Because remember, we have a flat grid for the actual ground we're walking around. And then we have a second flat grid that's the plane that's sort of in front of our faces. Okay. Well, let's clean this up a little bit. Let's get rid of we'll leave this first box, and node ground, we'll leave the ground. Okay, flat grid plane, let's get rid of this. Okay, we have a second transformation here, and for now let's just comment this part out, and node shape plane. Okay, what I'm going to do is I'm going to render the first box, the ground. Actually, I'm going to reorder these. Let me take this first guy here and the box in the shape node and move them below the ground, just so I can keep things a little bit more organized here. Shape for the ground. Okay. So we have our ground that we're rendering first, then we render our box, and then we have another transform node, and we're going to generate a second shape node. Now this second shape node is going to also contain the same geometry as the box. So we can actually reuse the geometry for the box as many times as we like. We only need one instance of it because it contains all the vertices for a box. However, we can have multiple boxes on the screen because if we create multiple shape nodes, each of those are going to represent a new box. So what I'm doing here is I have a second transformation here, and I'm actually going to move this transformation so that, well, let's see, where did I place my first box? Where was it? Okay, here's transformation. I'm taking it 0, 0, minus 3. Okay, so it's right in front of me, 3 units back. So what I'm going to do with this second transformation is move it maybe minus 1, or actually let's do minus 2, 0, and then minus 3. So it should be to the left of the first box that's on the screen. I'm going to add that in here, and then let's see here, pointer to a geometry, and this geometry points to a box. So I'm going to reuse that for the shape node here, and add node to shape, and this one's here. Okay, so I think this should give me 2 boxes on the screen with a plane underneath both of them. Undeclared identifier P shape. I just have to take this guy and put him on top here. Okay, let's try that again. Okay. Alright, so there we go. We have 2 boxes. One's straight in front of us, and one is 2 units to the left of the first one, and there it is on the screen. Now, my scene is actually pretty saturated in terms of the lighting, so I'm going to change the lights as well, just to make things a little bit easier to see. Light sources, point light, diffuse color, P light, set it, oh, I don't want to get the attenuation. I want to set the attenuation, and vectors 3. Let's see, let's try 2.00 and 0.0. This should attenuate our light a little bit so that it doesn't saturate the scene as much. Let's see how good this looks. Okay, that's a little bit better. Everything isn't overly bright on the screen. So what I did there is I just took the attenuation factor for my headlight and attenuated by a factor of 2. And I don't remember if I showed you this earlier when I was doing the point light source video, but this attenuation factor, we have 3 components. We have a linear, a quadratic, and constant values. And the way that this attenuation is if you go into the OpenGL documentation, actually, let me open that up. Okay, here under GL Light F, This is what we're actually changing when we set the attenuation. You'll notice we have GL constant, GL linear, and GL quadratic. What I did now is I changed the constant value to be 2. By default it was 1. And here under parameters you'll notice blah blah blah. If the light is positional rather than directional, its intensity is attenuated by a reciprocal of the sum of the constant factor, the linear factor multiplied by the distance between the light and the vertex being lighted, and the quadratic factor multiplied by the square of the distance from you to the objects. So the default is 1. So what I did is I just changed this to be 2, 0, and 0. So in other words, I'm attenuating the light by half of what it was before, so that it's not as bright on the screen. Okay, let's go back here. Okay, so now we have 2 boxes on the screen, and they're still both gray because we haven't created any materials. So let's go and actually create a new material and assign it to each of the boxes. Actually, let's create another box just so I can demonstrate the materials working a little bit more accurately. Okay, so I'm going to create another transform node here, a third one, and this one I'm going to move, let's say, positive 2 units, and it's back positive 2 units to the right, and it's back 3, so it's all lined up with the other ones. And here I'm going to reuse the box again for a third time to create a new node shape, and I'm adding it to the scene graph using the add node. So now we should see 3 boxes on the screen, all gray. Okay, and then there are. So we have the one on the left, the one in the middle, and the one on the right. Now let's go in and assign some materials to each of these boxes. So let's go to the very first one here, node shape. So what we do is after we create the node shape, we need to go and attach a material to the shape node. And remember, add node here is going to return an unsigned integer, and this unsigned integer is going to reference this node shape we create. So we can actually take the node value, save it here, so that we can use it inside of our assign material function that we just finished creating. Now, to use materials, obviously we need to create a material. So here we're going to call material, and we're going to create a pointer to it. So p material, and p material equals new material. And again, we have to check to see if p material is valid before we use it. Actually, I might as well just copy all of this. Okay, so not enough memory, cannot create a new material. Otherwise, if it created successfully, then we need to go and assign some values to that material. So p material, let's see, what do we want to change? Let's just play around with the color, which would be the diffuse value. So by default, I do believe, well, let's double check. Material was under, where did we put the material? Here it is. In the constructor, we set diffuse equal to 0.8, 0.8, 0.8, and 1. So we're going to need to change all of those if we want to change the color from anything other than gray. So diffuse we're going to set to, let's make it kind of like a reddish color. So first one's going to be 0.8, second one and third one are going to be 0 and 0. So this is going to give us a kind of a reddish material color. And after we create this material, we need to go and save it. And the way we save it is we need to go and call save material here. And by calling saveMaterial, remember this function, saveMaterial, is going to return to us an unsigned integer. And this unsigned integer is the value that we need to then use to go and assign a material to a shape node. So we're going to need another unsigned integer, and we're going to call it matID. And we'll call saveMaterial. And here we need to pass in our pointer to our material. Okay, so now we should have a ID number for our shape node and an ID number for our material. So after having both of these, we can now call assign material, and the material that we want to assign will go to this shape node. So we're going to copy that and paste it here. And the material we want to assign to that shape will be this UI mat ID that we've defined above. So that makes the assignment. Now, actually, what I like to do is I like to group things, just because it's a lot easier to understand what's happening inside of the code. And what I've done here right now is I've actually split everything up so that I have sort of a logical representation in terms of the scene graph, but not necessarily an easy one to follow. So let's clean this up. And you'll notice that as we're working more and more with the scene graph, our scene initialize function is getting larger and larger, and actually more and more difficult to work with, which we're going to fix eventually, but for now I just want to be able to show you how to get things working inside the scene graph, so that's why it's a little bit messy right now. Okay, so we have creating a scene graph. Let's group everything together. Here we're going to have making nodes. Above that we're going to have making let's see, we're going to have making materials here. And above this one, well, we don't have anything above that one yet, so we're just going to leave it for now. So where is that material I just created? I'm going to take this guy and I'm going to just put him up here. And I'm going to make 3 of these just so I can easily access them whenever I need them. So this is going to be material ID number 1. Okay, so making nodes, we're going to create our node. Oh, right, we need, the other thing here is making geometries. So the geometry we're going to be making here is the ground. I'm going to cut that out and just group it here. And the other geometry that we made is the box. So we can cut that guy out and, oh, where is this? Here. Okay, so we've grouped our 2 geometries. We have our flat grid, and then we have our box. And then our materials, right now we have only created 1 material. And then after that we have our nodes. So we have our transform node, and then we assign a nested shape node underneath that first transform node. Then we have our second transform node, and we assign a second transform node nested under that one. And then we're going to have our third transform node, and the third transform node has also a shape node that's nested underneath it. And did I miscount here? Let's count this again. Oh, right, because we have a 4th one for the ground itself. So we have 3 boxes, which have 3 shape nodes, and 1 extra plane for the ground, which has its own shape node. So that's why we have all these 3 items grouped here. Okay, so now which material or which shape do we want to attach this material to? Well, let's attach it to the very first shape, which was this guy here. Well, this is the ground, so we don't want to attach it to the ground, or else we'll have a red ground. let's attach it to the first guy here, which is the box. So after we call add node for the shape, we get UI node ID, and we can go and assign the material right here, right underneath this function call. So this should give us 2 gray boxes and 1 red one. Oh, and I forgot I renamed that guy. Okay, so that's the first one that we created, and we assigned it to be red. So as you can see, it's a red color on the screen. And now what we can do is go back up here, and we can go and create a second material. And this material, same thing, instead of making it red, let's go and make it green. And again, we're going to save the material inside of our container, and the container is going to return to us an ID number, which we can then use to assign to a new shape. And we're going to assign it to the second shape, which I do believe was the one on the left, right? So here we're going to take the ID number from this shape node, and we're going to assign the green material to that second object. I just noticed that one of our items here returned a warning. Oh, and the warning is just that we're not using that ID yet, and that's true. So that's okay. Let's give this a run, and there's our green one. So we have a red and a green one. And let's just do this for completeness. We'll create one more material, and we'll make this one blue. Now remember, the diffuse color here is red, green, blue, so whatever value I'm assigning here is actually getting assigned to those colors. If I wanted to make like any other color, then I can just mix these red, green, blue values together, and you can get any other color you like. So we're saving material 3, and we're going to go ahead and assign a new material to this last object, UI node ID, and we're passing in number 3. So you see, with all these functions, the way to interact with our scene graph is getting simpler and simpler, whereas before, whenever we wanted to change things like add textures, add materials, it was relatively difficult. We had to go and work a lot inside of the actual classes for each of the objects. But now we don't have to do that, because we've encapsulated everything inside classes and made things very modular. So we can attach a material, remove a material, swap materials. It's all very easy to do using our functions. Okay, let me show you one other thing here. Where are my nodes? Okay. We have our first node here, which is in the center. That one's fine. Or our first box, I mean. I'm going to move these boxes a little bit closer together. So instead of 2, I'm going to put them 1 unit apart. And the other thing I'm going to do is I'm going to name my nodes here. So I'm going to take the first one. I should really put some comments in my code so I can find these easier. Is this the first one? No, that's the ground. Okay, this is the first one. So what I'm going to do here is go pnode transform set name. And I'm going to call this one box 1. And the second guy here, pnode transform set name. I'm going to call him box 2. And the last one, oh, not the transform node, but I want to, actually, I made a mistake here. Or no, this is correct. I should be naming the transform nodes, not the shape nodes. So okay, no, that's correct. I was naming the transform nodes. For some reason, I thought I was naming my shape nodes here. Okay, so pnode transform set name box 3. Okay, now that my boxes have names, inside of the update, what I can do is I can perform many different operations just based on those names. So let me demonstrate. Before, we had to use this sort of notation where I had to know which node I was accessing using an ID number. Well, now instead of doing this, I can go and just search for a specific node. So I want to make sure that I'm getting a node transform back. Well, what I'm going to actually get returned to us is a pointer to a node. So MVP nodes, we need to pass in 0 because that's the very root of our scene graph, and we're going to go and call find nodes, and let's say I want to find box number 2. This function find nodes is going to return to us a pointer to a node. So I'm going to assign this to pointer to a node like this. Now, first thing I'm going to do is check to see if node is a transform, because it should be, according to the way that I've assigned names. And if it is a transform, then I can cast my node to be a transform node. Node transform, pointer, pnode, and then using the node transform, I can go and operate on anything that a regular node transform has. So what I'm going to do is I'm just going to rotate the box just so that we can see it moving on the screen. And I'll do this the exact same way we did it before, like so. So let's give this a try. Okay, so we see this, the red one was box 1, the green one was box 2, and the blue one was box 3. So this code here returns to us a node pointer, and using that node pointer, just based on the name, I can then rotate it on the screen. Now let's say I didn't want to rotate it about the y-axis, or I guess that was the z-axis. What we can do is back inside the initialize, for box number 2, if I can find it, box 1, box 2, what we can do is set node transform and set the rotation axis here, vector 3, to be whatever we want. And let's say we want it again 0, 0, 1, 0, 0, 0. Like so. And for box number 1, we'll have a rotation axis as well. And this one I'm going to make it kind of diagonal, like so. And let's go, well actually let's compile this just to show you that it is now rotating the green box like a top, like so. And we can go back into initialize, and where was it? Or sorry, not initialize, update. Inside update here, let's go and rotate the first boxes also. So again, we go and find node, and this time we want to find box number 1. If it's a transform, which it should be, we're going to go and rotate it, and let's rotate this one a little bit quicker, like so. Okay, and as you see, it's rotating kind of like on a diagonal. Okay, one last thing I wanted to show you, and that is the alpha. Remember that back inside the material, we have red, green, blue, and alpha. And alpha right now is set to 1 everywhere. Well, let's go and see what happens if we go inside of our scene initialize and we change the alpha value. I'll make, let's see here, where's box number 2, box 1, actually, box, what I want to do is change the material value, which is up here. Material, okay, so the red one was box 1, red-green one was box 2. So I want to give the green one a transparent look to it. So what I'm going to do is I'm going to change the alpha value for the green guy to be 0.5. And as a matter of fact, I'll do the same thing for box number 3 as well, which was the blue one. And we'll set this to be 0.5 as well. Okay. Notice something interesting. The boxes are not transparent. So can you guess why that is? Well, if you guessed because we didn't turn blending on, you were correct. You'll remember that before, whenever we went and used alpha, we had to make sure that inside of our render code we turned blending on. Well, right now, by default, it was turned off inside of our game engine. So inside of our node shape, we need to do a check to see if we should turn blending on. And if we do need it, we'll turn it on, we'll do the operations, and then at the very end of our render call, we're going to turn blending off because we don't want to blend anything else that is outside of this specific class. Now this is just like kind of like an optimization because we don't want to use blending if we know that our alpha values are 1, which means everything is opaque, because OpenGL has to do a couple more extra computations when blending is turned on. So if it's just rendering opaque objects, we want to avoid having to do those extra computations, which really wouldn't do anything because everything is opaque. So we can turn everything off. However, if the alpha channel is set to something that makes the objects transparent, then we need to turn blending on. So let's see how we can do this. First thing we're going to do is create a static member variable here, which is a boolean, and we're going to call it bObjectSolid. And by default, we're going to set it to true. So in other words, every time we go inside this render OpenGL function call, we're going to set this object solid to be true. Then inside the material, if we have a material, we're going to do a check. If the alpha value for the diffuse color is less than 0.997, then we're going to enable blending and we're going to set this bObjectSolid equal to false. So in other words, this current object is not solid. In other words, it's kind of translucent or maybe even transparent. So we set this variable to false. We then go ahead and do exactly the same thing we did before. Now you may be wondering, why did I only check the diffuse color? Well, because back here inside of our material, we're setting the alpha channel for the diffuse color. What we should really be doing here, though, is also check the other values for alphas inside ambient, specular, and emissive, because each of these also have an alpha channel. So let's go ahead and do that. Just copy this. So if this guy is less than 0.997, or this one's going to be ambient or specular or emissive. So if any of these have an alpha channel that is less than 1 or less than 0.997. Now the reason why I chose 0.997 is because there may be something that we do that's computationally calculating our alpha values and then setting them inside of our material. And if those happen to be close to 1 but not exactly 1, I want to still render them as if they are completely solid. So this is just like a check to make sure that I don't need exactly 1.0 to be the alpha channel. It could be something a little bit less, but not too much, or else it's going to start getting transparent. So let's just copy these guys here. So I'm checking all of the alpha channels for all the different colors we have, and if any of these have a value that's less than 0.997, then we're going to turn a blending on and set this variable. Okay, so then we go and we render our object on the screen, and after we render it, we need to do one last thing, and that is turn the blending off if it was turned on. And we know if it was turned on by taking a look at that variable that we had defined here initially. So initially it's true. So this here is going to be false because we have the not operator, which means we're not going to turn it off. But if we did turn it on here, then our variable was set to false, which means here this is going to evaluate to true, so we will disable the blending. Let's go and try this now. Okay, so we have our two objects that are transparent on the left and on the right. Now notice what happens when we go like this. We look through the blue box and we see we have the red box and the green box. We can see both completely through it. However, when we go over this way, we see the red box, but we don't see the blue box. The blue box almost as if it disappeared. Can you guess what's happening? I'm not going to tell you what's happening, but we will go and solve this problem a little bit later. It's an interesting problem, and as a matter of fact, I can demonstrate the problem even better if I were to do one last thing. Let's see here. Let's go back into our scene, into the materials here, and let's see, which one's this? This is the third one. I'm going to make the third one opaque, but I'll make the red one transparent, like so. And I'll show you what's going to happen here, and see if you can guess what's happening. So we have the green one and the red one transparent, the blue one completely opaque. However, when we go like this, we don't see the blue one. If we go like this, we don't see the blue one, and it completely disappears. And if we go like this, you'll notice we don't see the green one through the red one. Well, I think I just turned my light source off. So go see if you can figure out what's happening or how you can go ahead and fix this problem. Okay, so that's working with materials and different kinds of shapes. Remember, we only need to create the material once. After we've created it, we can assign it to anything we want. And we're not restricted to assigning one material per object. I never showed you this, but let's go quickly do this. Here we're assigning material. I can go ahead and reuse materials. So doing this will give us 2 red objects and 1 green one, because so I've created 3 objects, boxes. Each of these boxes are coming from the same geometry, and here I'm assigning red materials to each of the boxes. And I can say which box is going to have which material. It doesn't matter. I can mix and match. I can mix and match shapes because everything is coming from these containers that we created inside of our scene. Remember, here we have a container for lights, container for textures, container for fonts, geometries, materials, and notes. And I'm just pulling data out of these containers and using them however I wish. So inside of the scene, again, back inside initialize, here this is where we define the association between each of the values inside those containers. And the scene graph knows how to handle everything appropriately. So I hope you enjoyed this, and if you have any questions about the material stuff, feel free to post it on the website. Again, the website's www.maticnose.com, but I'm sure you know that already since you got this video. And if you want to see more videos coming your way, feel free to click on any of the Google ads on the side, because each click helps me out financially and I can keep my website up and running. Okay, so come back again next time where we'll be going and adding textures to our existing objects.